This is the second half of section 10.5b. In this section, we're factoring equations that have not equal to 0 beginnings of our quadratic formulas. In this instance, we have a scenario where we have the 2x squared being negative, and we'd really like it to be positive in order to factor. So I'm going to try to make my x squared positive by adding 2x squared to both sides. I now have my 0 on the left side, which is perfectly fine. 2x squared plus 1x minus 15, and that is equal to 0. I'm going to have to use the MAC method here. You remember the MAC method talks about multiplying to the first number times the back number, so we multiply to negative 30, and then we add to the middle number of adding 1. Since our multiplying factors are negative 30, we have 1 and negative 30, we have 2 and negative 15, we have 3 and negative 10, we have 5 and negative 6. Each of these adds to the following numbers. Our last one is close to what we want, adding to negative 1. However, since it's the opposite of what we want, we take the negative 5, the positive 6, and those add to positive 1. And that is our choose, standing for the MAC method, multiply, add, choose. Because we don't have an x squared term, it's a 1x squared, we can't use our shortcut, so instead we're going to factor by grouping 2x squared minus 5x plus 6x minus 15 for our problem. We look for a GCF coming out of the first part of the problem. The GCF between 2x squared and 5x is just an x. We then take that x out, leaving 2x minus 5 on the inside, and a 2x minus 5 also at the back. We then have to consider what is going to have to multiply and go in the box to have the same problem work out the back. Well, we take negative 15 and divide it by negative 5, and that's obviously positive 3. We check it by saying 3 times 2 is that 6, and it is. This lets us to allow our factored answer be 2x minus 5 times x plus 3. We now take each of our two answers, split it into half, and complete the problem. Adding 5 to both sides, dividing by 2, gives us an answer of 5 halves. On the other half, we subtract 3 from both sides, and we get x equals negative 3. Our solution then is negative 3, comma, 5 halves. This could also be written as 2.5 very easily in the problem. Let's look at the bottom problem. This is our last example. In this last example, we have 16x squared equals 9. If we're going to solve this by factoring, we have to once again set it equal to 0. So we're going to subtract 9 from both sides to get 16x squared minus 9 equals 0. As we consider this problem, we realize there's only two terms, and both of them are perfect squares, with a minus in between. So this is called the difference of two squares. The difference of two squares, if you remember, factors into conjugates. Conjugates are exactly the same factor, except there's one's a plus and one's a minus. So 4 times 4 is 16, so it's 4x and 4x. 3 times 3 is 9, so it's plus 3 and minus 3. These are conjugates. We take each of our two answers, our factors, and we set it equal to 0, and solve the resulting problems. Subtracting 3 from both sides on the left gives us 4x equals negative 3. We divide both sides by 4. X equals negative 3/4. We add 3 to both sides on the right. That gives us 4x equals 3. We divide both sides by 4. That gives us x equals 3/4. So our answer is negative 3/4 and positive 3/4.